Okay, we have two forces. Both forces they are given to us in IJK format. That's the good news. And then we like to solve this problem using both vector approach and a scalar approach. We want to find moment about point O. So the question asks, find moment about point O. So I want to use the vector approach and the scalar approach. So on the vector approach, I have to say again for force F1 and force F2. So remember, moment about point O from the force F1 is equal to R cross the force F1. So the R start at the point, which is O, go where the force F1 is. The force F1 is at point B. So it's going to be ROB. I need to find the coordinate of point B. Can you help me with that? How much the coordinate of point B is? Okay, the Z is 1, right?
2.
Very good.
Negative 1.5.
-1.5 and 1, right? So that's where ROB is. Then for F1 is already given to me in that format. That makes my job very easy. So let's do that. So I'm going to get ROB, which is going to be IJK, ROB, which is 2 minus 1.11, and F1 is minus 300, 150, and 200. So this will be equal to I minus J plus K, and then I can just simply do it like this. On the I cover I. Right, if I cover I got minus 1.5 times 200. Minus 1.5 times 200. Minus 150 times 1. Or 1 times 150. Done with this. I'm going to put my pencil on the J when I do for J. So 2 times 200 minus, so 2 times 200 minus 300 into 1, or 1 into minus 300. Next one, for the last one, the K, you cover K, and then 2 times 150. Again, you remember that it was like this, right? If you have the little determinant A, B, C, D, you can say AD minus BC. So in this case, it's going to be for K, if you cover it, it's going to be 2 times 150 minus 1.5 into minus 300. So all I need just to simplify the answer. So in here, minus 150, and then I have 1.5 into 300. So this will be 300. Minus this will be minus 450i. Down here you have 200. So 400 plus 300, you get 700. Minus 700j. And lastly for k, I have 2 times 150, which is 300. 1.5 times 300, which will be 450. So 450 minus 450, the answer is minus 150 in K. Hopefully I did it right. Now, again, for now, let me just to focus on the scalar approach for force F1 to see whether I got the same answer. Then I can repeat the same thing for force F2. So on the scalar approach, the first thing that we do, we put the component of the force up there, where it is. So I have minus 300 in I, so it actually is going to be something look like this, pointing on the negative x. So you have 300 here. On the, again, I didn't put minus 300 because it's already is on the direction. When I draw it, you don't put negative on it. On the z, I have 200. and on the y I have 150. So let me draw that table. So I'm doing moment about x-axis, moment about y-axis, moment about z-axis. We do this table because we don't want to omit anything. We don't want to miss them. So the first force is 300. I'm going to just put 300 here. And I'm going to put a little I on there just to remember that force for x. And then I have the 150, which is on the y. And then 200, which is on the k. I didn't put the negative here. The negative will make you confused. Sometimes you multiply by negative. In a scalar approach, positive and negative is coming from clockwise or counterclockwise rotation. So let's focus on the force 300. The force 300 down here, I like to do moment about x. The force is on the x, moment is 0. I don't need to do anything. The next force, force 150. The force is on the y. We do moment about x, distance will be on the z. The z distance that we have is 1. So it will be 150 times 1. I just need to find where the direction of the rotation of that is. So if you consider this about the x-axis, you stand there, you can see your rotation is clockwise. So it will be minus 150 times 1, and this is coming from the fact that's clockwise. The force 200 is up there. I do moment about the x-axis. The force is on the z, moment about the x-axis, distance will be on the y, which is going to be 2. 200. So sorry, I need to a little bit digest. So I do the force 200. The force 200. That force is on. I guess down here I made a mistake in my calculation. If that's the fact. So the moment about the x-axis, and then we use the 200. 200 here. Yeah, that's something that make my mind busy because my answer doesn't match the answer here. In here is 200 times 1.5. I made the mistake here. You see, when I cover this, it actually is right here. So I need to come here. I do moment about x-axis. That's the x-axis. Then the force is on the z, the 200. Distance will be on the y. So maybe down here we have the mistake. You see, when we put x, y, z here, that's where we have the mistake. And I do not know where I put the 2 here. So this is actually was the opposite way, right? It was minus 1.5, 2, and 1. So all the calculation here are wrong. The good news or the bad news, they are all wrong because the position was wrong, right? You see, you have here minus 1.5 on the x, 2 on the y. I put it the opposite way. So that's why all the calculation here will be wrong. That's why my answer didn't match here, and that was a little bit shocking to me that why we didn't get it the same thing here. So moment about the x-axis, that distance was there, so I just need to find the direction of the rotation. That thing about x is going to go counterclockwise, so it will be plus. The answer here is 400 minus 150, which is going to be 250 I. So the answer here is wrong. That will be 250 I. You see, your answer should match on both cases. In a scalar and vector, your answer should match. Moment about y-axis. When I do moment about y-axis, I need to consider the first force, 300. The force is on the x. I do the moment about y. The distance will be on the z. So it will be 300 times 1. And then that's about y is going to go clockwise. So minus 300. The next one is 0 because the force is on the j. Distance is on the y. That would be 0. And the last one is 200. The 200 force is on the z. I do moment about y-axis down here. The distance will be on the x. So 200 times 1.5, and this is going to go plus. So you have 300 here and then minus 300 here. This will be 0 in J. And then on the Z, moment about Z axis, we go with the 300. 300 is going to go counterclockwise. The distance is 2. Like you see, the force is on the X. Distance will be on the Y. And then I can repeat it for the rest of them. So for the 150 down here about Z, that's going to go clockwise about Z. Minus 150. The distance for this is 1.5. And the last one is 0. So minus 150 times 1.5 plus, I need to use my calculator for this one. So we have 600 minus 1.5 times 150. Got the big number. Oh, I forgot to put the... Yeah, 375. Okay, so again, I'm not going to post this recording because all the